share. I think recording is okay. Can you able to see my screen?
Yes.
Okay, very good. Okay, now we can start. Hello, everyone. Thanks for your time, for joining this session. So today we are going to look at how and where we can start cloud journey and what we are proposing you here, AWS. So if you want to start your cloud journey, the first and biggest vendor in this cloud area, and it is one of the hyperscale cloud providers, AWS. And the entry stepping point to the AWS is Cloud Practitioner exam. So in this session, we want you to help you and guide you to start your cloud journey. I hope it will be useful for you. So let's start. Why do you need to get AWS certification? According to Jefferson Frank is also one of the AWS recruitment partners. They have a good survey about this. According to their latest survey, if you get AWS certification, all the reported guys, at least 70% of them, they are reporting their salary is increased at least 20%. And it is now known fact that if you don't have AWS certifications in the IT area, and if you want to do new things, it is becoming difficult because if you look at the job market as well, if you search the job market, I am located in Belgium, but it doesn't matter. Just go to LinkedIn or any job searching site and just search the IT jobs related to AWS or cloud. And you will amazed with the amount of available jobs in the market. And we have a really supply demand problem because people are thinking it is difficult to enter to this market or transition their old experience knowledge to this new area, and there is no way to go. But there is a way. So there is always a first stepping stone you need to take. And this AWS Cloud Practitioner is one of the point. And why AWS itself? Because if you look at the statistical about AWS size, AWS itself is representing 1/3 of the all cloud market share. So I think it makes sense to start the cloud journey with AWS as well. But of course, you can ask, how should we start? It doesn't matter if you are in IT or very professional, you are coming from different background. For us, what we can tell you, what the matter is enthusiasm, curiosity, and also a little bit passion, because the breadth of knowledge, the volume of knowledge as well, it is huge in the cloud, because in the cloud, you have to know networking, you have to know security, you have to know all the operating system underlying structures. So we need knowledge, all these subtopics. Yes, it is quite extensive. It is overwhelming sometimes, But if you take easy approach one by one with enough passion, I think you can do this. So let's talk about this entry point exam, AWS Certified Cloud Practitioner exam. If you want to start AWS certification, this is the basic certification we are suggesting to all people. So where should I start cloud? Let's start with cloud practitioner. It is a good starting point. Why? Because it will give you basic cloud concepts. It will mention what is shared responsibility model in security and what are the compliances and which kind of technology stack in the cloud we have now. Because if you look at hyperscale cloud providers, more or less, they have similar kind of services. Even the services features are very looking each other. And of course, in the cloud, most of the services are pay as you go. So, but we have also some reserved capacity things, billings option, and you have to understand also billing pricing. It is metered billing. It is different than what we get used to on-prem environment. And this cloud practitioner exam consists of 65 questions. They will give you 90 minutes. You can take this exam either on-site exam center or remote via Practitioner. And it is more or less a good price, $100. If you pass this exam, you will get also voucher for the next exam. So it is really important to get and pass this exam to be able to continue your cloud journey and getting other certifications. Meanwhile, if you have questions, don't hesitate to interrupt me or put something, your comments on chat window. So meanwhile, I am also following those things. So what is next after this session? What we planned today with ITGilde, we planned this session, but after this session, if you prepare yourself and if you can spare time working on AWS Cloud Practitioner, so we are going to arrange a second session, a follow-up session on top of this at 5th of July, 6:30 p.m. European summertime. It is, you can also see on ITGilde website. So in this session, we will try to solve questions and we will do Q&A with you and we will give some exam tips and tricks. This session also will be free and it will be context session. So we will ask questions like exam-like questions and the winner, it will be like gamification and the winner will get these nice Tuxdroid, Linux droids. If you want to get more info, you can reach us aws@itgilde.nl. This is second event after this. The third event, what we are planning, if you can afford and if you can spare time, we want you to move more and going one step further with AWS SysOps Associate certification. So we planned 6 evenings. We will start at 6:30. We will go at 9, 10, whatever it takes. And we will prepare you to take also SysOps Administrator exam certificate. And at pricing point, we are thinking €300 for ITGilde members and $450 exclusive one for non-members. And if you want to book yourself to this limited seat training, you can go and check this booking URL. If you have more, looking more knowledge, information about this training itself, don't hesitate to contact with us via this email. Who am I? So, I'm computer engineer, pure engineer, but half of my brain is engineer, half of is business, always. So I did my master on engineering management. I always work in IT environment. And currently I'm working as a DevOps cloud operations engineer in AirTime's wireless networks. And you can contact me via LinkedIn, or you can follow me in LinkedIn. You can follow our blog post on DevOps Mania, or if you have other training inquiries, you can send to ITGilde. And I am official member of the ITGilde Academy. So Necip has a question, why SysOps Administrator, not Architect Solution? So it depends on your a little bit background. So if you have kind of a little bit sysadmin experience and knowledge, we suggest to go for SysOps Associate. So it is more hands-on and it will easily get familiar to you all AWS services, Necip. We have crowded agenda today. Welcome. We have 10 topics. Normally, if you go and take this training, it usually takes about 6 or 8 hours. So in this 2.5 hours, we will try to zip and we will try to give all demystified information to you. I hope we can achieve. If not, don't worry. We will follow up at 5th of July. So in these 10 topics, actually, these are the topics you will see and you will solve exam questions. The exam questions will pop up from these areas. First, we will start to look at Amazon Web Services, and we will look at what is the computing layer in AWS, what kind of compute services we have. And after understanding this compute layer, we will look at as well the global infrastructure, how they are connected to each other. In networking, we will go a little bit deep dive on network side. And on the other hand, we will look at storage database options we have. And in the security part, we have to understand shared responsibility model, because in the cloud, since we are putting our applications data into the cloud, we have some responsibilities to do. And also cloud vendors has some things on their plate to do. So we have to understand, according to the service that we are going to choose, this shared responsibility model and the responsibility, the total amount of responsibility is changing. So we moved our workloads and how we can monitor, and do we have something on analytics? We will look at also these options. And meanwhile, we have to understand these pricing, how the pricing is working on cloud. Is it really like electricity billing? So when we shut down all the resources, no cost. If we forget, then we have lots of bill or not. How we can migrate our resources. So we will look at some couple of migration services. And at the end, we will give you some cloud adoption advice. Let's start introduction to Amazon Web Services. But of course, before going to looking Amazon Web Services itself, we will give you, and we want to meet with you on a common ground with understanding what is cloud computing first. So what is cloud? It is computers are flying on the cloud, because in my profession, I always had a difficulty to tell my kids what I am doing. And especially with the cloud area, it is getting more difficult. When I say my kid, I am cloud expert, they said, what? So it is also getting difficult, but we have common terms. So when we say cloud, generally, if you are in the IT area, more or less you will understand, or normal regular tech users, they will understand there is some servers or services on the other side of the internet, and we are consuming these services, right? This is what we say cloud. You listen your music from Spotify, you watch your TV series from Netflix. If you look at all these are services you consume remotely over internet. But when we say cloud computing, it is consuming all these on-demand resources. What kind of resources? It is networking, storage, computing, memory. So all these computing power, storage, all these things, we are consuming on demand on a metered link. And if we don't want to use, if we don't need to use, then we are going to shut down. So this is cloud computing. Remotely, on metered billing, easily scalable, and also can shrink. When we say cloud computing, we have to understand this. So what kind of benefits we have? Okay. We want to do cloud computing, but what is in it for me? You can ask this question. First of all, we don't have upfront cost. Normally, in the on-prem environment, if you want to deploy an application, you have to allocate all these servers, right? And you have to make a procurement. You have to go to find your software application vendor. Either you will develop yourself. Yeah, you have to create all these stacks apps, all these networkings, firewalls, everything, and you have to invest in it. You have to prepare some kind of money. You have to really negotiate with your CFO. Hey, we are going to start this project. Can we start this project? We need this money, because without that money, on-prem environment, it is difficult to do a project. But in cloud, you don't need to do. On the other hand, in the on-prem environment, since we did the procurement, it is like, I'm always giving this example, having kid. Okay, if you decide to having a kid, then when you get a kid, you have to show your parenting, right? It is like that. If you decided to deploy an application, or if you want to build a service, then you have to build all underlying, all these hardware, software, all these stack up. So somebody has to do maintenance. But in the cloud, you are not responsible for all these maintenance stuff. The other thing, on-prem environment, if we are getting a server from the door of our data center, we should plan today plus ahead. Because I have to plan the normal, if I have a predictable traffic, I should look at my load traffic, the usual traffic. I should look at also peak, and I should add the growth percentage, because I cannot do negotiation with CFO, with finance team several times. Just go to your company and just think yourself how many times you are doing procurement. It is every year or every 6 months. But in cloud, you don't need to guess the capacity. Yeah, you have to. It is really bold word. I don't want to say this, but it is a marketing word. At least you don't need to do much more really bits and bytes capacity planning, calculation, like we are doing on-prem, let's say. You have to, because in the cloud, everything is on metered billing. It is like following your electricity bill. You have to follow all kilowatt, but here you have to follow everything as a service, every API call. So you have to follow this capacity as well, but not like on-prem environment. The other thing, let's just imagine a small market. It is taking some goods and selling back, right? So just think the economies of scale. We have also big market, supermarket chains. They are buying in a bulk and very big amount. So these hyperscale cloud providers, especially Amazon, when they get enough amount of users on their service, they decrease the cost. And when they buy CPUs, memories, they buy in a bulk, millions, zillions. But just imagine yourself, I'm a simple company, I have 3-tier applications. How many servers you can buy? And how many times you can buy? We don't have budget, we don't have time. So we cannot get these benefits of economies of scale, but these cloud providers can. So at the end, there's a race condition, I cannot compete. It is not economic to build services on my own. That is the issue. Let's go to other reasons. I remember from my other work experiences, when we order a server, it usually takes 40, 50, 60 days. Can somebody tell me if somebody gets 2 weeks in a server? 1 week, right? It is impossible. But in cloud, as long as you are not running in, let's say, strange region, because in cloud we have as well, because in cloud, these cloud service providers, they are doing capacity planning and they deploy certain type of resources to certain regions. They have also procurement problem with the nowadays chip issues, right? But as long as if you are running in the crowded region, you will not have any issue. When you want access, you will get. It is the speed, because business wants to do something. I want to try this thing. But as an IT guy, you hold, oh no, you have to wait 40 days. What? 40 days. But the market is gone. The market is gone. Sorry, vendor is not supplying earlier than 40 days. That is the excuse we are always giving to business side. But then business say, hey, these IT guys, they are not understanding us. But now with the cloud, we can understand them, because what they ask for us, we can give immediately, because we have this agility. The other thing, if our business is expanding to the different region, just imagine yourself. You have to find the data center providers. You have to check all the regulations. If you are really working on highly regulated environments, you have to check all these licenses in the data center. You have to make very detailed SLAs. Why? Just go to cloud, pick up the region, and check their audits reports from third-party trusted vendors. And if it is okay, go. It is easy. So this cloud is providing this capability. It is lowering the bar to make yourself, your company, a global player. It is really game changer if you look at this perspective. If business or an IT guy looking cloud, it is just another data center, I think they are really lacking and cannot understand this cloud differentiation, because the differentiation factor of cloud is it can make you another kind of Facebook, another kind of Apple, Google. You have this underlying infrastructure. You can do whatever you want. It is just a limitation of your vision and dream. That's all. Okay, these are the benefits. I want to go to cloud. Then what kind of service models I have? In the cloud, in Belgium, we called it IaaS, Infrastructure as a Service, PaaS, Platform as a Service, Software as a Service. So we have two differentiation depending on your service model selection. Of course, we have DB as a service, function as a service, container as a service. These X as a service is going more. But of course, who is responsible from what is changing. On-prem environment. Yes, thank you, Isaac. So on-prem environment, you are responsible. So we, Blue, we are responsible for everything. I have to procure all servers. I have to find good storage. I need to get a good virtualization hypervisor. I have to deal with all operating system patching, technical patching, security patching, networking. I need to plumb all these things. I need network boxes everywhere, here and there. And this should make me redundant, highly available, Oh my God, I need a CI/CD on top. And we are all responsible. On-prem, this is the situation we are doing every day. But if we get infrastructure as a service, now below the operating system tasks, virtualization stuff, server handling, storage, networking, all these heavy lifting, we are leaving to service providers from whom we are getting the service. If you are getting this from Amazon, this orange stuff, virtualization, server handling, storage, networking is under responsibility of Amazon. The blue, if I start to use IaaS kind of services in Amazon, let's say we will mention of them, AWS EC2, such as it is providing a virtual machine, then I am responsible of selecting operating system in it. Then, of course, the other layer on top of this. But at least I'm not giving time, energy, effort to the underlying layer. But if I select platform as a service, now I went a little bit above. I am not responsible. I don't want to do also operating system patching. I don't want to follow up operating system end of life cycle. Who cares? I don't care. Then, of course, if you don't want to much care, then it means you are offloading these tasks to your vendors. If you offload these kind of tasks, it should be charged. So whatever you offload, how much you offload, you're also going to be charged. Don't forget this. Of course, you will create time for yourself to create your business or application. You will focus on that. But in the meantime, this kind of service price is also getting a little bit higher. And also flexibility. You are losing also flexibility. So there's a trade-off always. But in software as a service, I don't care cloud. Do I need an accounting software? Okay, I'm looking at accounting as a service software. Do I need a file drive? Then I'm looking at file drive. Or do I'm looking at contact center? I'm looking at contact center as a service. That is the beginning. So it is depending all your company. How is it looking cloud? Where do you want to start? How do you want to adopt? Do you have enough power, enough resources, enough skill set? Because all goes hand in hand. You cannot go with regular guys, sysadmin guys to the cloud. You have to train them. Then you have to spare a training budget. And you have to spare a little bit budget for external consultants to give you guidance on this cloud journey. So it is not always free, all these things, right? So if you want to do, it is like going on vacation or taking a trip. If I stand here, there is no cost. But if I go to shopping, there is a cost, associated cost. So if I go cloud, yes, there is a migration cost. There is a handling cost with both environments. When you are going to cloud, you have to maintain cloud. You have to maintain existing environment. Plus, you have to maintain existing migration activities. And you have to pay training, consultants, everything. But once you are in the cloud, then done. You can go everywhere. So I think we are clear. If you have any questions, doubts, comments, please share. If you look at the deployment models, which kind of cloud models we have in deployment? So where I can select these kind of services, you can select in public cloud. We have public cloud providers. As I said, we have Amazon AWS, Microsoft Azure, Google GCP, IBM, Alibaba, Huawei, DigitalOcean, goes on, goes on. So you can take your services from public cloud, you be checking your regulatory requirements. This is also important. But if you cannot, let's say you are in a healthcare industry, manufacturing or defense industry. In defense, I don't believe you can move everything to public cloud. Or in government, I work also in government. It is difficult to move everything in cloud, especially in Europe. We have GDPR. You have to think twice, maybe 10 times what you are going to move to the cloud. So in private cloud, it is dedicated to us. But when we say private cloud, if we are getting a private cloud service, it should be on metered billing. It should be on-demand scalable. It is not like the old way, getting servers, paying money, throwing money. No, it should be metered billing. Okay, who is allocating what? How long my job ran? How long? What was the capacity, the CPU memory, storage amount? So all should be metered correctly. This is how it should be in the private cloud. The community cloud, we usually see this in government. Like in Belgium, we have also community cloud style. In most of the Europe countries or other countries, we have centralized cloud, and all these centralized cloud used by the different ministries, and they share the cost with each other. It makes sense. But maybe it can be a company as well, right? You have a multinational global company, and you have different labs across different geographical locations. So different countries can or should use these community cloud resources as well. Hybrid cloud, it is mixed. So we are mixing public cloud and private cloud or any kind of combination. These are the deployment models in cloud computing we have. And since our main guest topic today is Amazon, if you look at Amazon quick facts and figures, Amazon is founded in 2002. Amazon AWS, actually Amazon is founded, sorry, before than this, but AWS idea was creating an internet operating system. So the current CEO, Andy Jassy, was the initiator of this Amazon Web Services. So he made a team, and they started to think why we are not giving these services and selling these services to outside. They first thought we have to centralize and industrialize these services across all Amazon. They did this first. Then the second thought, they hit their brain, why we are not selling this to outside? We already industrialized this internally. Everything is metered. Then they give and try to sell these services. But of course, the maturing up all these services and releasing, announcing them took 3-4 years. And in 2004, 2006, they came up with first S3 object store service, then EC2, and every year they add up different services. So now currently they have more or less 200 services. Do I know all these services? Not yet, but depending on the situation requirement, we are learning, because since everything is coming from the same software factory, you understand how they are developing, how they are approaching. At the end, look and feel of all the services are more or less same. So you can guess how it behaves. They are operating in 26 geographical physical regions on Earth, and they announced 8 more. And these regions are, we will mention what is the relation with region availability zone. They have also currently 84 availability zones, and they announced 32 more. So they are owning the 1/3 of the market share. And for the 11th consecutive year, Gartner, I think you know Gartner, it is well-known research company in IT world. 11th year, consecutive years, they are the market leader in cloud area. So this is why we are started with AWS, and why we are proposing you to also start your cloud journey with AWS. You are at the correct point. So I called it lab, but if you are in this session and if you don't have still AWS account, just go and please create an account yourself. It is easy. You have to provide a valid an email address. This email address is very important because the first email address when you create your account, we call it root user email, and it is very powerful. So you have to take care. This email address, you have to protect this, and you have to provide a valid credit card. But the Amazon itself, it will give you the biggest free tier. What is free tier? It will give you enough room to play, but don't forget to delete all the resources when you create. Otherwise, you will surpass the free tier. Yeah. So then the free tier, it will be enough for you, because in Cloud Practitioner, nobody is expecting you to solve the biggest challenges. In Cloud Practitioner, what AWS is expecting you to understand the cloud concepts and how services are composed each other, and for which use case, which services are used. This is what they are looking for. So it is like one-to-one match. Oh, I have this use case, like I need a database. Okay, AWS as a database service. Simple, one-to-one logic. So meanwhile, in the background, you can go portal.aws, amazon.com, billing, sign up, and you can get your free tier account. So let's look at compete services. Okay, we decided to use Amazon, AWS services, Amazon Web Services. Which kind of compete services we have? We will look at all these options now. Compete in the cloud, the most and famous and the most mature service, because it is one of the earliest service is announced. Elastic Compute Cloud. This is basically a virtual machine for you in the Amazon environment. The pricing model, we will try to understand this, how we can scale our EC2 environment. Then if we need to do application integration, we will look at a couple of integration services we have. Then we will try to understand, do we have other options in computing or not? So if you look at these AWS Amazon.com/products compute, you will get these massive compute options you have. The first and foremost service you have to remember, Amazon Elastic Compute Cloud, EC2. This is basically giving you a virtual machine that you can do whatever you want. A Linux machine, Mac machine, Windows machine, just select your operating system, select your instance type underlying it, then you are good to go. If you want to scale these things, grow and shrink, that is the cloud fundamentals, right? You can use Amazon EC2 Autoscaling. And if you're a really beginner, and if you don't want to deal with all these internal bit and bytes, but still you want to use cloud, then we have Amazon Lightsail. Amazon Lightsail, they are providing a really lightweight dashboard, a separate dashboard. In the background, it is launching an EC2, but all these things are masked for you. It is like just spinning up simple servers, simple databases, simple network connectivity. It is getting simple hosting services from simple hosting providers. Then if you want to go with that way, Amazon Lightsail is the starting point. Maybe hosting a blog. My DevOpsMania.com is hosted on Lightsail. I am not taking all these EC2 burdens, even I am expert on this. Lightsail is easy. Amazon Batch, if you have kind of workloads that you need to run only in certain amount or in certain time, then we have Amazon Batch. You still, also I have to explain this. In Amazon, we have bare services, bare bone services, and we have also services are using these bare bone services. So they are generated more services like Lightsail. Is Lightsail is really a service? No, it is really just a cosmetic change of EC2. if you look at, if you open the cover, it is EC2. It is Amazon batch is as well, more or less like this. So we have container services, Elastic Container Service, ECS. We have registry. If you want your own registry, public or private, if you want to put your container images in it, they have Elastic Container Registry. If you want to do Kubernetes, but you don't want to manage Kubernetes control plane, then they have AKS, Elastic Kubernetes Service, and all the underlying hardware in all these container services. If you don't want to manage, but you want to manage by AWS, then you can go with the Amazon Fargate option. That is also good. Burak, I don't want to use servers. Don't tell me about servers. Do we have something serverless? Yes, we have Amazon Lambda. It is one of the major function as a service system in the market. You can develop your code in certain application runtime. Then you can put your code, your code will be run just on Amazon Lambda without dealing with underlying infrastructure. So it is basically a good starting point for your serverless journey. Let's say you have a requirement and you don't or you cannot put your resources, or you want to run them on your on-prem, or maybe in the mountain somewhere, it doesn't matter. You want to run your workloads not on physically in Amazon data center, but your own periphery, in my garden, in my home office. Then Amazon itself is also acting like a hardware vendor. It is also a game changer. With these outposts, they will ship you a full rack full of servers. They will ship you. You have to put your data center or whatever your place, just plug in the cable. Then you can run your EC2 instance on it, databases, storage, containers, Kubernetes, everything is included. You see, they are not just staying in the cloud area, they are also threatening and entering our on-prem environment with these kind of services. And it is also making our life easier to transition, to move to adopt cloud. Because if you can use all these services in on-prem environment with outpost kind of services, then of course it will be easy to use all these rest of the services in the cloud. In the computing option, we have also PaaS, Platform as a Service. As I said, in all these service models, Amazon AWS, Amazon Web Services, it is not giving you one service. We have different kind of services, and in each service, your responsibility is changing. Who is responsible for what? Don't forget. And in PaaS, PaaS, Platform as a Service, Elastic Beanstalk is the good example. I want to deploy my application like I am deploying on application server, Tomcat, Whitefly, GBus, whatever it is. But I don't want to deal with underlying infrastructure. It should scale, grow, shrink, grow, shrink. Which service can I use? Elastic Beanstalk. Good. The other thing, AWS local zones. I think we have to mention this later. So we have, when we deal with regions availability zones, I will mention these local zones. Now leave this as it is. So what is EC2? Elastic Compute Cloud. It will give you secure, resizable, basic virtual machine. Like we are running on-prem, we have KVM, VMware, IBM, Dell, HP, we have many hypervisor vendors, right? We are creating virtual machines on top of these hypervisors. If you want to run virtual machine on Amazon, if you want to spin up your server, that is EC2. And Amazon is using Zen hypervisor, but it is customized, of course. So but you have different options. You have different CPU, memory, storage, networking, and purchase model combinations as well. And it is supporting Intel, AMD, ARM processors. And Amazon started to develop work on their ARM processors. So now they are threatening CPU industry as well. They are going to be player in the CPU market. Can you imagine? Recently, they started to give as well the on-demand Mac instances for all these Mac developers. Because if you want to develop something on Apple world, you need this machine, unfortunately. So it doesn't matter whatever you are running, whatever you want to run, machine learning, SAP, high performance computing, grid computing, you have an option. Then you have different combinations. So EC2 is providing all these combinations to us. Okay, what kind of instance types we have? All there are the same. If you go to ocean, all fish are same. Yeah, they are at the end fish. We have different fish. So EC2 as well different because all our workloads are same. Some of them are memory hunger. Some of them are CPU hunger, right? The workload, or maybe some of them is IO intensive. So we have different instance types. The first one is general purpose. If you don't care, if it is development testing environment, then pick up these general purpose instance types. These general purpose instance types, you will see the computing, CPU, memory, storage, networking, they are correlated. So there is no big difference between all these resources. To give you, for example, the instances with starting T2, T3, or Mac instances are general purpose instances. If you have resources that require CPU intensive tasks, then you have to select compute optimized instances. They are starting with C4, C5, C6, C6. They are ideal for, let's say, mathematical calculations, financial calculations. I don't know, whatever you are doing in your application. If you need to do relying on CPU cycles, then this is the correct place. No, you need memory. Instead of CPU, you need memory. Okay, don't worry. We have memory optimized instances as well in Amazon Web Services. They are, yeah, if you, as I said, the proportion is bigger. The memory proportion to the CPU is bigger in memory optimized. Accelerated computing. If you want to do GPU card things, if you need these kind of things, they have also different computing services. And the last one is storage optimized. So if you need local storage, high volume of storage, you need to read and write immediately. We have also, like data warehousing, we have also these storage optimized instances. And don't forget, don't buy in. It is not like a marriage, right? Just try. If it is not going to work, then change the instance type. You can stop your instance, right-click, change instance type, then try your workload with that one. It is not like on-prem environment. Oh, we bought this server, but we cannot do whatever we want to. Yes, because you signed the contract, you already paid. You have to live with it. It is like a marriage. But in the cloud, no, I didn't like it, then delete, right-click, delete, terminate, finished. In the cloud, you have this agility and speed. You can test easily. If it is not going to work, forget. If it is working, keep it. Then, how pricing is working? We have different pricing. The first pricing model is on demand. What is on demand? I'm entering the market. I want one Coke. What you will get? You will get one of the available cock on the shelf, right? It is like that. I entered the Amazon console. Hey, I click, launch. The first one is on demand. So I didn't make any commitment. I didn't give any promise. I didn't pay in advance. This is on demand. It is ideal for short-term, irregular workloads, development, testing, but you can use also in production. It doesn't matter. But Amazon is not giving you a guarantee underlying capacity because you are not making any commitment. Why Amazon should do capacity planning based on your on-demand workloads? So the second one is savings plan. If you want to do commitment, let's say you did a small study and you are going to run your workloads in a certain amount of time. Okay, then it makes sense to get the savings plan. 1 year commitment, 3 year commitment, half paid, full paid, depending on your choice. This savings plan will get you 66% discount over standard on-demand pricing. Very good. But of course, if you are 100% sure that workload is going to run for that allocated time. Reserved instances, what we are doing, we are making commitment on certain type of instances. And if we run those kind of instances, then those instances billing is automatically reduced with our reserved instances billing. It is also perfect. The spot, the fourth one, I did the reserved, but I am not using. Am I miserable guy? No, you can sell it back in the market. So we have a sellers. Here in this condition, Amazon is not the seller. The other users are sellers. You, me, someone else, because I cannot use. The plan is changed, the project is canceled, or I couldn't get all these user ramp up. I don't have this user. I have spare capacity, but I am billing as well. I want to get rid of this. So what I can do, I can put it back to market. So if somebody is putting that back to market, then of course we have also buyers. Then 90%, 80%, 70% cheaper than on-demand spot. And the price is always lower than on-demand. Max is equal to on-demand, but you will get always cheaper instances with spot. What is the bottleneck? Your workloads can be interrupted because since it is fluctuated market, if there is no enough capacity, or if somebody wants to get use, or if somebody paid more, if demand is increasing for those instance types, of course you will lose your spot instance. So your workload should tolerate these kind of interruptions, let's say. Dedicated host, I have really silly license requirement. I need to license software on per core, on per machine. I cannot go any machine that everybody is using. I cannot share a physical machine. I cannot go cloud. No, you can go cloud. If you pay more, we have an option. You have a dedicated host. With this option, Amazon Web Services will allocate a rack, a machine for you. Then your CPU ID, machine ID will be always same. You don't need to negotiate with your vendor. You are cheating on your license. These are the pricing models. So we don't have one pricing. It is not like electricity. In electricity, we have day billing, night billing. So we have other billing option, maybe weekend. But here we have 5 different options on pricing. You have to think of. Based on your allocation, based on your project plan, what you are going to do, who is going to use all these services, what is the plan? So based on this future forecasting, you have to select the correct EC2 with these pricing models. It is not finishing oh, I will choose compute optimized instance. Okay, I am done. No, it is not done. You have to select as well here. What is the other option? How you are going to pay? Okay, we decided on pricing. We decided on which kind of EC2 we are going to run. Now what we will do, I don't want to deal all these scaling options, scaling in, scaling out, vertical scaling, horizontal scaling, all these kind of scaling things. Can somebody do it for me? Yes, we have EC2 auto scaling. If you create your EC2 virtual machines in this auto scaling group, and if you define reasonable logical policies according to your demand workload, it will grow or shrink. The metric, it can be CPU metric, memory metric, network metric, whatever metric you choose, based on that metric or based on the load that you are getting to your application service, it will scale, grow, shrink, grow, shrink. Nobody look at this. The auto scaling group is responsible for handling all these capacity for you. And it is not just one size fits all. In auto scaling group, you can put different kind of EC2 instances and you can weight them. So according to weight, actually you are creating a total capacity. Based on this total capacity, it is adding up different instances or removing instances. So you are not obliged to run always same kind of instances. Of course, it is better to run same kind of instances. Otherwise, there will be differentiation between the workload consumption and also production. But you don't need to put always same. So it will give you different options for scaling. As I said, what we have as well, we have in serverless AWS Lambda, in container world, we have ECS. It is the control plane from AWS. It is like looking like Docker Swarm. It is announced before Kubernetes or around Kubernetes, but it is lighter than, of course, Kubernetes. Kubernetes itself is difficult to manage, difficult to install, difficult to use as well. But if you don't want to get all these hassle of Kubernetes control plane, you can offload all these Kubernetes management plane to the Amazon, and you can use Amazon AKS. And the beauty is, if you like, and if you want to use this on-prem, they have Amazon ECS anywhere. They have also Amazon AKS everywhere. I think anywhere, everywhere. I could mix the marketing term, but you can use same kind of service type either on Amazon hardware or your own hardware. It will manage remotely from Amazon side. Do you have any questions till now? Are we going fast? Is everybody is okay?
Yeah, it's fine, Burak, thank you.
Okay.
I have one question, Burak.
Yes, Carlos.
Yeah, in terms of the budget issue in the Amazon also, we want to get this certificate from the Amazon, but we need to know the budget issue also to serve our clients, to be aware of the budget or comparison with other cloud systems.
The budget, usage budget, you mean?
Yeah, for choosing the Amazon or choosing the Azure, which one is best? We need to know that those comparisons to serve our clients or not.
Carlos, actually, it is a good question. It is difficult as well because why? It is like which BMW is good or Mercedes good. It is if you do side-by-side comparison among usage practicality of all these services or your total cost of ownership when you start to use these services, it really totally depends on your organization. Let's say in your organization, if you have already some Azure experts, maybe it is started from Azure, but the stepping curve is more or less same. So they have similar kind of services. The pricing as well, it will be similar at the end, because they are in both sides. They want to get their customers from each other. And if you really start to use all these services from one vendor, you will get also discounts after certain time. So it is really better to stick one vendor. But of course, there is also price associated with it. If you stick to one vendor, then it is difficult to negotiate, right? On-prem, we have a possibility to go with different vendors and threaten one to each other. But on cloud, if you want to do multi-cloud, these kind of things as well, you have to hire all these professional people from all these cloud vendors who knows both cloud vendors. You have to maintain developers who knows all these services and API differentiation. So it is costly.
Yeah.
For a small and beginning company, startup company, it is difficult to go with multi-cloud or doing a comparison. It is just a strategical choice. It doesn't matter either this and that. At least one of the three biggest, it is enough. But for biggest companies, of course, they have enough resources, they have enough time, they can invest, they can go multi-cloud, they can look at which kind of services A cloud provider A is providing, cloud provider B. So they can they can listen all these demos, POCs, they can decide. But I cannot advise small or startups to go multi-cloud or doing a comparison or spending time to comparison actually.
Definitely, yeah. Okay, thank you.
Welcome. We will go a little bit, then we will give around 5 or 10 minutes break, coffee break, pit stop, then we will continue. So let's get application integration. Okay, we selected our computing layer. Our applications are running in these compute layers, but now they have to interact with them. And we have to do interaction. If it is monolithic application, so we have these two jargons you have to know: monolithic applications, microservices. Monolithic means everything is side by side together. So you have your presentation layer, business layer, data layer, they are more or less same, or at least 3 tier. So this is called monolithic application. So you have, let's say, payment. You don't have separate payment service or booking service, accounting service. They are all one service. This is monolithic application. But in microservices, let's say you have a booking side. The booking service is different. Customer service is different. Payment service is different. Notification service is different. So this is microservices approach. In monolithic application, you don't need much these kind of integrations, but when you started to break all these pieces in the monolithic application, and if you differentiate them to the different services, then you have to orchestrate these small islands, right? You have to make a bridge like this one. Otherwise, how you will connect and how these services are going to interact with each other. The other way, let's say the login service. The usage amount of these services are changing. In microservices world, some services are getting really huge peaks or transaction per second, but some services are getting less, like login. You have login less, but maybe payment less or booking high, right? So it doesn't make sense to accommodate them into the same place or give resource. So this is the reason why we are separating them, splitting them, making them microservice. Because of these scale issues, deployment issues. The other thing, let's say I am frequently deploying payment. I am putting new features, but maybe I don't need to put new features to the login service, right? So with these decoupling, I am also differentiating all these development tracks of all these services. But once I separated all these services, when we go to microservices approach, how I will integrate them. So if a client made a booking, then he makes payment. So booking payment needs to talk. Then if the payment is successful, I need to send last notification to the maybe owner, land owner, the hotel, I don't know. You see, lots of services needs to interact. Because of volume they are getting, because of speed of processing is differentiating, we have to use some kind of services. Then we have these integration services. SNS, SQS, Event Bridge, and if you want to orchestrate all of them, step functions. We have also a couple of others, but in this exam, you have to know all these 4 gang members. SNS, it's a publish subscribe service. We will mention briefly later on. SQS, these are proprietary, developed by Amazon, sold by Amazon Web Services to you. They are managed, so you don't need to deploy yourself a notification system. It is kind of platform as a service or software as a service to you. You just need to know how their API is working and how you can interact with these services. That's all. Then in your services, in your own applications, you can make them talk with using these components. So it's a plumbing. This is really difficult. When everything is in mainframe, our life was easier. But now we put them out. It's like I always saying, it is like a monster. Now we put the monster outside. Now our job is integration job, actually. Integrating all these smaller pieces one by one. So how SNS is working? Simple notification service. SNS, if you look at the screen on the left-hand side, we have publishers. We have publishers like media publishers, broadcasting. Hey, I have this, I have that, I have this, I have that. They are event publishers. They are generating events. In the middle, we have Amazon SNS service. In this Amazon SNS service, we have different topics. You can have one-to-many unlimited topics if you want. You can put any message on these topics if you want. And on these topics, you can get subscribers who is listening, like listening a radio channel or listening a TV show. These kind of things. Maybe I will show a comedy TV series. My kids will watch Walt Disney. These kind of things. So we can get different subscribers. We have publishers on the left side. On the right side, we have subscribers. Publishers are responsible for generating events. On the right-hand side, we have subscribers. They are subscribing to these events to consume or to do something. We have differentiation in these subscribers. It can be a person, a real human, or it can be machine to machine, application to application. So on the bottom, you will see application to person, A to B. So in my phone, if I register my phone to get this system, let's say I deployed my services and my services are getting unusual traffic. So I will create an alarm. The alarm service is publisher in this case, right? Then it will create alarm. It will put this event to Amazon SNS. Then if I subscribe this Amazon SNS with my phone, now you cannot see, maybe you can see, with the phone, okay, I will get a message, oh, you are getting unusual traffic, 10%, 20%, or your instances are starting, or your applications start restarting frequently. Look at this. Simple infrastructure. This is, of course, infrastructure level. You can do whatever publish subscriber model you want. In these topics, if you choose standard topic, message order, it is not guaranteed. So I can give you an event that is already passed maybe 3 hours ago, but maybe your subscribers is already consuming an event happened 5 minutes ago. If it is important for you, and if you don't want to implement any other logic in your application to follow up these orders in the event generation, you can use FIFO. I don't know how you can pronounce. First in, first out. With this, of course, it is a little bit expensive from the normal one. It is following strictly ordering, and it is also preventing message deduplication. So it will deliver it once, exactly once. Then based on this, I don't want to put much more logic on the subscriber level. Otherwise, of course, as I said in other previous slides, if I am escaping to do some responsibilities, if somebody else is doing, so I have to pay for it, right? It is makes sense. This is the economy, the basic economy. So the FIFO is expensive than standard topic. On the application side, what can you integrate? You can integrate SQS, Lambda. SQS is queue service. We will mention in next slide. We have serverless Lambda, so we can consume all these events. We can do something about with these events, or we can call an endpoint, HTTPS endpoint. Or AWS has a high ingestion service, Kinesis they call. From Kinesis, you can branch to different service. You can go to S3, Redshift, OpenSearch, we will mention, or you can use third-party tools, logging, eventing systems. This is SNS, and it is quite common in the exam. If you are planning to get cloud practitioner exam, you have to know this illustration. SQS, it is simple queue service developed by Amazon. It's a proprietary. We are not dealing with the underlying infrastructure. We are just using as a queue. That's all. So on the left-hand side, again, we are producers. They are putting workload task items on this queue. On the right-hand side, we have receivers. They are consuming all these things. Again, if the order of all these items are important for you, and if you don't want duplication, then we have FIFO queues. You have to pay more. It will prevent the message duplication, and it will give you only one-time delivery. I hope the difference between SNS and SQS is clear. Do you have any questions till now? Isaac made as a question, before I choose an option, will AWS give you an estimated price? Yes. So we have an AWS pricing calculator. You can search on internet, whatever you are going to deploy, Isaac. So just select the services, which kind of services you want, which kind of resources under those services you are going to deploy. So you can get easily an estimate. You can do same estimation with other cloud vendors as well. So they have all price calculators. And of course, don't forget the discounts. Yeah, if you stick with one vendor, you will get discounts. Maybe you will get other plans. But if you are not sticking one vendor, of course, you will get normal list pricing, right? It is usual. Market is, Amazon is doing same. SNS and SQS difference is really important for the exam. SNS is pub, subscriber notification service. We have different publishers. We have different kind of subscriber. My phone can subscribe as an SMS, email, or I can call Lambda, whatever it is, HTTP endpoint, but SQS is just a simple queue. I'm putting some item, and on the other hand, I have workers. Their workers are consuming those items. So in this computing side, we have one small lab. We will do this lab, and after this lab, we will take a break, a small break. Okay. So you still my screen, right? Okay. So this is AWS Management Console. It is one of my accounts under my hand, so I'm using it. If you hit this, this is the new AWS dashboard. If you like it or not, it is card tiles-based approach. It is kind of admin dashboard. It is just giving you quick facts and figures about your cost. If you have any issues within your environment, it will give you some advice on what is happening in your account. Let's say you are using an EC2 service, right? And there is something happened on underlying hardware, then that hardware needs to change. So your EC2 instance will gone. So AWS needs to notify you, and this is AWS Health Dashboard will give you. All the rest of the services, if you want to reach, you can click on these services. These all services are categorized. And if you want to make them bookmark, just select the relevant service for you. Let's say in compute, I like EC2, just click and it will give you a quick short bookmark here internally. Or if you want to type, let's say EC2, it will give you suggestions to go to which place. It can be real service or the resources under these service. If you want to do account activity, you can go to your account billing dashboard. You can see all your bills. And earlier the support was here, but they removed to under this question mark. If you want to open support ticket, this is the place you can open. And in this today, I hope we will mention also all these support plans. But in this lab, we will create a virtual machine. And we know now the creating virtual machine is happening with EC2. But of course, if you create your resources with clicking here and there, it is difficult to replicate. It is difficult to repeat, and it is difficult to audit as well. So in the cloud area, especially on-prem as well, we have infrastructure as code jargon came up. So every cloud vendor, more or less, they have a specific way of deploying resources. So for Amazon, if you want, you can deploy your resources with web console, with clicking here and there. Now I will do. Or you can use CLI. They have a CLI command line interface. You can download that CLI and you can install that CLI into your PC. You can use that CLI to create resources, but of course, again, it is not repeatable, auditable, replicatable. So forget this as well. You can use CloudFormation. CloudFormation is a templating, custom domain language. You write according to Amazon spec. If the service is supporting CloudFormation, you are writing all the resource definition and pushing this definition to Amazon, and all these resources are created for you. This is one way. So console, CLI, CloudFormation. The fourth one is SDK. So you can interact with your Amazon Web Service account software development kit. For well-known programming languages, they have SDKs. With SDKs, you can create, delete, manage all your resources. Recently, they developed also Cloud Development Kit. So it is an abstraction, CDK. You can also use this. Or from third-party vendors, like HashiCorp, we have Terraform, and Michael is also here. Michael, from ITGilde, Michael is giving Terraform training. If you want, you can join. If you want to learn Terraform, like from third-party vendors, we have also a provisioning frameworks or templating structures, like from HashiCorp, Terraform, or we have Pulumi. We have many others, but I cannot remember now. So these are the ways for creating resources in your cloud account. But for the test and showcase purposes, now I will go and click. Because the other ones, is learning curve is a little bit high and we don't have enough time, but you can at least to get the feeling, understanding of all these services. That is what I am doing. Let's say Amazon is launch a new service. Most of the time, or not 100%, they are not supporting all these service resource creation with all these templating thing as well. So the web console is always a choice. So I selected EC2. I select launch instance. I want to create an instance. Here I give a name, ITGilde Cloud Practitioner, just give a name. Here I can select different operating system types. That is possible. Ubuntu, Windows, Amazon Linux. Amazon is also, they have their own Linux distro. Red Hat, SUSE, Mac, Debian, you can choose. Amazon Linux, I choose. So then we have, yes, it is selected. It is 64-bit. That is okay. I am fine with this. After selecting operating system and type, so we have instance type. Instance type is a machine type. Which kind of machine? As we mentioned, we have compute optimized, memory optimized, different options. Now I will go with T2 micro. When studying your exam, it is better to select these kind of small instances. If you see free tier eligible, it means when you open your AWS account, it will give you enough room to play. So I select free tier because I'm not going to do anything. A key pair, if you want to connect your instances, then key pair is important. If you are not using one service from Amazon, it is SSM, but you don't need to know now. Let's say, if you click create new key pair, it will create a new SSH key pair. You can create one if you don't have. I have already one, so I select it. In the network settings, of course, this instance should land on a network. It should connect somewhere. So I'm selecting one of the network I have. If you don't have any network in your account, you can just go to VPC, search virtual private cloud. We will mention briefly in the upcoming slides. Then if you click on VPCs, here you have a create default VPC option. So you can create your networking for your instances. That is also possible. But I have already done this. So don't worry. Here, security group is a firewall. So I will create a basic firewall. And I want to allow HTTPS traffic. Let's say install allow HTTP traffic from internet as well. And it says auto assign public IP disabled. So I want to change this behavior to give also public IP to my machine. And these are the rules. So what I will do, I will change to SSH. I will narrow down. You can give any IP range you want. Who needs to access, from where needs to access, it totally depends on you. Nobody's deciding except you. So here, I will connect SSH from my location. This is my IP, but HTTPS HTTP 000. It is everywhere, basically. The storage, it is the root volume where operating system will land on. I am fine. The rest is fine. So I selected operating system type, instance type. I arrange the networking from where I'm going to access, how I'm going to access. The storage, do I need storage or not? Then launch instance. That's it. But of course, since we have done this on console, if I do next time, maybe I will forget one checkboxes. So it is really important in the enterprise level. You created these resources with auditable or Git oriented manner. Then everybody is tracking what is going on in your account. Otherwise, also for standardization, right? You will deploy an application or you will deploy in a database. Somebody is picking up a big instance type for the small database with 2-4 tables. And for business critical database, you are selecting a small T3 micro. So you should track who is doing what is the standard, what is the tagging, who is going to billing, because in the company we have, we are always working for either for ourselves or for other companies. So we have to track which project we are working, right? Which department is launching these things. So all these resources should be tracked. How you can going to track? If I click this. But as I said, for showcase purposes, we have done this with clicking. So here I have instances. It says initializing. So it is launching the instance. Here, if you go to instance, you can see the details of the instance in the underlying pane. So on the left-hand side, we have all these sub-resources in this EC2 service. And here, the Excel table style sheet, we have all the instances listed. And if I click, I can see the details of my instance. And if I want to perform something on this instance, start, stop, terminate, or changing some configuration on my instance, I can use action button. It will, if you want to refresh, you can use these refresh buttons. It will be available. So if I want to connect, it is important to know which machine image you are selecting. So I selected Amazon Linux distro. Usually Amazon Linux distro username is EC2-user. So based on that, it is important, because if you say connect, I don't have these options now, session manager or either thing, SSH client. You see it says EC2 user. This is my instance public IP. I can connect. And my location is, if you say ifconfig Joe, I am in Belgium, Mol, and this is my IP, and I give my IP permission to access this server. So if I try this, I should be able to connect as long as I have the connectivity. Let me check the instance. I have a SSH client here. I have a SSH client. if you created your key pair, a new key, SSH key pair, it will immediately download key pair to your local. So yesterday, I think I created one, ITGilde Cloud PEM. And if you look at the key pair name, ITGilde Cloud. So if I want to connect my instance via SSH and look at the security tab here, it is now allowing security SSH connection, sorry, this is SSH connection port 22 from my IP only, and it is the other HTTP are open to internet. So this security is firewall. What I am expecting, so if I say connect, if I copy this on my local client, so SSH, the key is ITGilde Cloud PEM, it is already in my local, and this is the user I'm going to use, and I connected the instance. So this is the instance we have. If you look at, it is small instance, 1 GB memory, and 1 CPU, we select 2 CPU. So here, if I want to, this is the operating system. So since we launch an EC2 instance, now upgrading, always keeping up to date all the packages, I am responsible. Amazon is not responsible, right? All the other packages, applications that I am going to install on this operating system, all the life cycle of all these packages and applications, I am responsible, not Amazon. So you have to keep always in your mind, when you deploy a service resource in the cloud, who is responsible of that? I created EC2. Okay, it is secure. Yeah, if I open this SSH access to all of the world, Amazon is not responsible for this. I am responsible. So I should be aware and wise to open ports correctly, because it is shared responsibility model. And you will get several questions in the exam regarding this. Chris, sorry, we are not providing slides. Can you share this? Honyin, yes, you will see this event recording in YouTube, ITGilde YouTube channel. So you can watch, you can see, you can stop, you can take notes, but we cannot provide slides. Gökhan, could you share the link, please? Which link? The login link. Yeah, thank you. See you, Isaac. Next time. We have a follow-up session, don't forget. So we have the instance launch and we can connect. Let's say, let's install a package. Let's do a check update. If we have any update, it is better to check. Amazon Linux is Fedora Linux distro, Red Hat, same family. So they are using yum package manager and sudo yum install, let's say install Apache, sudo systemctl start this service and enable this service. Okay, so if you look at, do we have services now? Yes. And I installed simple Apache, that's all. It is running. It was available in Amazon Linux package repository. It is running. If I put my application, it should run. But of course, I have to check also instance firewall. but I'm not going to check now. So this was the short lab, and we will give a short break. After this short break, we will continue. If everything is okay. In the next sections, we will go with the global infrastructure. So we will try to understand the global infrastructure. So let's give a 10-minute break. Is it okay for everyone? Let's give 10-minute break. So in my time, it is 10 past 8. So 20 past 8 is in Europe, Belgium, Netherlands, Germany, let's say. I don't know the rest. So we will give a 10-minute break. Then we will come back. Okay. Okay. I hope everybody is back. So we will continue. And now we will try to understand from where Amazon is giving these services and how their global structure is made up. So let's look at this. When we say AWS global infrastructure, we have to understand the regions. And under regions, we have availability zones. We have edge locations, local zones. I didn't mention in previous slides, and the management aspects.
Burak,
Regions.
not share your screen, right?
Oh, did I forget to share? Thanks, Carlos. Is it okay now? Can you see my screen?
Yeah, now okay, yes.
Thanks for notification. So regions. When we say AWS regions, what you should understand. Regions are geographical area, physical area on Earth. So they are located on these countries, locations on Earth. If you look at the map, so the blue one, the blue regions like Milan region or Stockholm, Ireland, Paris, Sydney, Northern Virginia, Oregon. These are exist regions. So you can deploy your resources when you select. I don't know how you are going to deploy your resources on Amazon. You have to select the region first, because in some services, we have regional dependency. Like EC2 instance, An EC2 instance cannot run at the same time in Milan and Paris. So it should be really in a physical location. You have to select this. And these regions are compliant with data governance in local authorities. They are highly available and they are chosen based on the demand the customer is asking, and because of also pricing options, electricity pricing, infrastructure, the technical handling of all these data centers. So Amazon is making their due diligence and opening these regions. But regions itself are connected with fiber network. It is on Amazon network itself. And in regions we have availability zones. Availability zones are single or group of data centers, but they are located far enough to not be affected by a disaster. So regions are made up with availability zones. And each availability zone, let's say in this example, I give you Frankfurt, I choose Germany, Frankfurt itself, EU Central One, Frankfurt itself as a region. Then in this region, we have 3 availability zones. Then 3 availability zones means I have 3 different collection of data centers. EU Central 1A, 1B, 1C. So when I deploying, let's say I want to deploy AWS EC2, then I can select which availability zone that I want to deploy, or I can select any AZ in the same region that I want. That is also possible. These availability zone data centers, they are connected with high available, redundant, high throughput network. So you don't need to worry about all the connectivity in the availability zone itself, also in the region itself. All these networking part is handled by Amazon. You don't need to worry. And all these data centers are audited also from third-party companies. So they have certain certificates, specifications, achievements already. But beside of these regions and availability zones, we have also edge locations. Edge locations, they are local sites. They are very close to our users. But of course, the total infrastructure, when you compare to availability zone and region, it is less. Because in the edge locations, we just want to serve our application, maybe website. The purpose is getting close to end user. So CloudFront, it is the content delivery network service from Amazon. It is using these edge locations on Earth. The number of edge locations is bigger than the total regions actually. So edge locations is used for caching. You can check the edge location site. Maybe even in your country, you can find an edge location, because edge locations are really a pop places. They have deal with all these internet or telecom service providers. So we mentioned this AWS management, how you can manage your resources in AWS. As we said, you can do your click on management console, or you can explore all the services. You can use AWS CLI. You have to install the CLI yourself. Either you have to install to Linux or Windows. We have a couple of options, or if you are techie and if you want to deploy something, you can use SDK or CDK, Cloud Development Kit or Software Development Kit. Or if you want to use Amazon AWS proprietary templating language to deploy your resources, then AWS CloudFormation will help you to create all these services and resources underneath it. These are the ways to interact with AWS Cloud API. You can interact with all these ways. So we have a small quiz. Who is ready? The question: which component of the AWS global infrastructure does Amazon Cloud Front use to ensure low latency delivery to the end users? AWS regions, A, B, H locations, C, availability zones, D, virtual private cloud. William says H locations. Do we have other answers? Other guess? Alp +1. Onyin B. Yes, that is true. As I expressed several times, H locations are used heavily by Amazon Cloud Front Service for delivering all the contents that we have published on Amazon itself, not the others. Thanks, William, for the first response. This is the global infrastructure side. In the exam, you will get the different questions. What is regions? What is availability zones? What is H locations and local zones? I didn't mention local zone. Local zone is also kind of H locations, but it is not only used for H cases, but let's say there is a high demand in particular country to the Amazon resources, but they want locality. Or we have a highly industrial center location. Let's say in Belgium, particularly, I'm located in Belgium. In Belgium, we don't have AWS data centers, unfortunately. We don't have European government data centers, unfortunately, as well. But we have a local zone. So if I want to deploy and if I want to close Belgium market, and if I want to use AWS, then I can choose AWS local zone, Belgium local zone. So you have to check also the local zone where it is, if it is fits for you or not, because the number of services that you can run on local zone is less. Like EC2, RDS, storage, containers, then that's all. Supporting services is or less. So now let's look at the networking part. How networking is working or not working in AWS. As I said, everything in AWS side, it is connected within their network. Once you get in the AWS, all the regions, all the availability zones, all the data centers, they are connected to each other with highly redundant, high throughput fiber network. They have their internal marine, even ocean networking. You don't need to worry about all these connections, but how it is really working. So this is a typical networking diagram you will see. The region, this flag is representing the region. So when we start to operate in region, let's say I selected Germany, Frankfurt as a region, then I want to deploy their EC2 resources. Before deploying EC2 resources, I have to establish a networking. And networking is VPC, Virtual Private Cloud. It is dedicated, isolated networking in my account only for my workloads. In your account, if you create a VPC with the same range, we are not clashing. There's no jeopardy in the network. There is no clash. It is all virtual network. In your account, you can use all these RFC, I couldn't remember the number, private subnet ranges. You can pick whatever you want. And in my account, I can pick whatever I want. Then based on this selection range, the VPC range here, in this range, they chosen 10.0.0.0/16, right? For all region. Then in region, we have to create subnets on this big IP range, because don't forget, we have availability zones and we have to deploy our resources, some resources, not our resources, availability zone. So those availability zones also require IP ranges. So I have to slice this pizza. For VPC, we are defining a range, 10.0.0/16. And for each availability zone, we are also slicing cake pizza, 10.0.1.0, which is one availability zone, one subnet, and the other subnet. you can create, for each availability zone, you can create subnets, or you can only create one subnet for only one AZ. Maybe you are fine, you don't want any redundancy, high availability, blah, blah. You are fine with only one AZ, then okay, just open one subnet, one availability zone, that's all. Then after configuring this, in configuring all these networking in VPC and availability zone subnet level, because subnets cannot span across different availability zones. There is always one-to-one. One availability zone, one subnet. One. You cannot use one subnet in two availability zones because they are different locations. Different locations, but they can route traffic each other. Within your region, every machine, function, whatever you are deploying, and if they are attaching a network interface, and if they are getting IP from 10.0.0.0/16, they can communicate with each other. Whatever you do, it doesn't matter. They can communicate with each other. There is no restriction between AZs. But let's say for some kind of resources, they want to go directly to internet. So in this case, if you let them directly go to internet, this is we call public subnet. In public subnet, we are putting an internet gateway. It is kind of a proxy. And with the help of internet gateway, they can directly go to the internet. In the meantime, on internet, traffic can be initiated as well towards your public subnet interfaces. That is the trade-off. But if you deploy your resources in private subnet, there is no direct internet gateway attachment. So your resources cannot use internet gateway. They have to use a NAT. So they are going outside with NAT mechanism. So network address translation mechanism. Either you can deploy NAT gateway, you can deploy your NAT server, whatever you want. So basically, all the rest of the traffic needs to go outside. It should go via this NAT server or NAT service. Then we call this subnet private subnet. So what we are doing with this way, we are protecting our resources, so workloads running on private subnet. Because even if you forget to configure something, since nobody can launch externally towards our private subnet, they are a little bit, let's say, not fully protected, but at least protected, instead of when you compare the resources residing in public subnet. Do you have any questions here till now? In AWS global infrastructure networking, is everything going good? Okay. So these are the networking options, but how we can connect from my location, my enterprise to AWS. The first, I have to set up my VPC. Okay. I define my VPC. I pick up the range, IP range. I am fine. While picking up VPC range, you have to be really careful. There are several blog posts on Amazon site as well. There are also new services like Cloud WAN service. I couldn't remember the exact name. So there are several ways to establish networking in your AWS accounts or AWS structure. So don't make it rush when setting up networking in AWS, because once you deploy your resources, it is difficult to get it back. The first thing is how I can connect my resources in AWS. As I said, you can use public subnets. We just deployed an instance in public subnet before going to break, and that instance can directly go to internet gateway, and it was available. Still, I have to check the firewall rules, why This simple Apache is not responding. But meanwhile, you can also communicate with your resources over a VPN. There is really a next wizard on AWS. You just need to initiate for VPN connectivity. You select the IP destination, the vendor, which machine box you are using. Then it will give you a bunch of configuration, a single configuration file. Then you run this configuration file in your, I don't know with what VPN vendor you are using, then you are ready. Your VPN tunnels are up to your AWS environment. So from your data center, HQ, on-prem environment to AWS, you can communicate also over VPN. That is possible if you don't want to go plain on internet. The other method is, Burak, internet is good, but it is slow. VPN is secure, but slow. I want security plus speed. Okay, just give me more money. Then we have a direct connect. This is also a good option. So basically, we have direct connect locations. AWS is providing us a network partners. Depending on your location, you talk with one of the network integrators partners. Then physically, you go plug in your cables in those direct connect locations. Then you have a direct link from that moment to the Amazon data center. Very good. But of course, we have several options in direct connect, depending on your traffic within your HQ and Amazon. You have to select the band. It is different pricing, different structures, but we have also this option. It is very good. Subnets and network access control list. This one is also coming in the exam. If you want to do cloud practitioner or also other AWS exams, you have to understand the difference between security group and network access control list. Security group is stateful. NACL or network ACL is stateless. What does it mean? What I defined while launching an instance, I said I want to connect my instance via SSH protocol, right? SSH protocol default port is 22. I selected my home outgoing IP address as the source. The target is server, and I allowed this. Where did I allow? In security group. So security group, if you look at the security group itself, security group is working on instance level. It is stick to instance. This is the instance network interface. Then next to it, immediately your security group. It is working on the instance, or it can be other thing. Security group is also working on any network interface. So whatever is getting a virtual network interface from your VPC can have the security group structure. So it can, we don't need to narrow down, always talk about EC2, because Lambda can be attached to VPC as well, or your containers can get IP also from your VPC structure. But Hello.
We hear you.
Sorry, I dropped. I don't know why. Why talking networking I dropped. Amazon cut my connection. I am sorry for this inconvenience. I will continue. Share screen too. Do you see my screen?
Yes.
Okay. So these are the three possibilities that you can connect with AWS, either with directly to your resources over internet without any security, or establishing VPN and going over your VPN tunnels, but you are limited with your VPN capacity, or you want security plus speed, then the direct connect itself is best option, of course. And we were mentioning this stateful, stateless. I think I dropped in that place, right? So the exam will ask you what is best to protect the resource. If you want to deny a certain IP traffic, then network ACL is best, because in security group, you cannot deny, you can only allow IP addresses. So one is allow whitelisting, the other one is whitelisting plus blacklisting. Allow listing or deny listing, let's say. It is more politic, democratic now. So this network ACL is acting in subnet level. It is outside of your resources, interfaces. The security group is inside. It is attached to interface itself. But the network ACL is outside boundary in your subnet. So everything is going in and out is filtered with network ACL. So if I allow a package traffic inside to my subnet with network ACL, if we change the default rules, you should always allow the outgoing, because it is stateless. It is not keeping state. It is the difference. But in security group, let's say in my security group, in my EC2, I launch and I am trying to going to a different location to download package. I am initiating traffic from my EC2 instance to outside a different location. But once the traffic is returning back, is security group is allowing this? Yes, because it is stateful. So it is recognizing the traffic. It says, he is initiated this traffic to outside. He is looking the allow list on security group. It is not in the list, but it is okay. He is initiated, so I will let it in. But in network ACL, it will not do this. It is the difference.
You are in. Yeah.
I'm really sorry what is happening. I didn't understand. I am getting blue screens. Yes, Egypt, it can be a problem of Belgium or my location. I don't know. And it is funny, while I'm speaking networking, my network is going away.
Yeah.
Ah. So DNS, I think we are clear in the networking structure. Now we go to DNS. AWS has their own DNS management service. It is Amazon Route 53. It is funny because the DNS protocol itself is working on port 53. So in US, these highways are really popular. So they make this genius idea to connect all these pieces, and they called Route 53. So it is also domain registrar. You can buy a domain name. You can move your domain names. You can manage your domain names. You can create subdomains with the help of Route 53. It is possible. Beside of this, it can help you also different DNS routing mechanisms. Normally, you cannot find, only you can find in enterprise level DNS services. So if you don't have much information regarding DNS, DNS is the phone book of the internet. Like I know only my number and my wife's number, that's all. So I don't know my friends, my father, all these phone numbers, right? Nobody's recognizing anymore. So we are human and we cannot recognize these IP addresses, 10, 20, 19 to. It is difficult. You cannot keep all these numbers in your mind as soon as you are a memory champion. So this DNS structure, domain name system structure, is helping us to translate google.com, I don't know, ITGilde.com to the .nl to the relevant IP addresses. Behind the scene, this conversion is happening, and your client, either you are using an application, your browser, is finding your target, the next target. So in Amazon side, if you want to manage DNS, the correct place, the service is Route 53. In Route 53, you can create two kind of DNS structure. One is private. It means it is all happening in your account. Whatever you created as a domain, whatever you associate a dummy IP from your VPC, let's say dummy.example.private. I have created a private hosted zone like this, dummy.private. It's a domain name you can use. So you want to associate services, maybe database host names, service names, load balancer names, whatever it is, with this kind of internal structure. Then you have to use private hosted zone. It is only to you. Nobody else can change or use this. But beside of this functionality, we have also public hosted zone. In public hosted zone, we are managing our public domains. So whatever I put this as a record, it is visible for the outside world as well. Not only applicable in Amazon Web Services level, but also outside level. You can do. Let's say I bought a domain name, Burak blah blah blah.com. Then I have to create a public hosted zone. Let's say I created a service, mail.burak blah blah.com. Then I have to create this subdomain name also using this public hosted zone. So public hosted zones are containers of all these collection of all these records. But public is for public side, private is for private side. I hope this differentiation is clear for you. Okay, we can manage networking with Route 53, but if you want to route traffic to the different locations inside the same region, which kind of options we have? We have elastic load balancing. So Elastic Load Balancing is also another service from Amazon, AWS itself. It is getting network interface in the subnets. And if you deploy your resources into different availability zones, so with the help of those interfaces, it can route your traffic. You don't need to worry how I can route traffic between different availability zones, because load balancers will help you. And with their features functionality, it is easy to attach a certificate as well. So Amazon itself is domain name registers. They are also trusted certificate authority. So you can buy certificates. And from AWS, if you buy your certificates, from that moment, you can easily attach your certificate to these load balancers. It is really useful, handy to use together. Load balancers, EC2, Autoscaling group, they are perfect for managing, putting your workloads there. Do you have any questions till now? Chris should use H location. It is for me or for answer? So now we will look at storage and databases. We are halfway to all the chapters. I hope we will try to go as much as we can. Then we will finish the rest in our follow-up session. Then in our follow-up session, we can also solve different questions together with the gamification, because we have a contest there. We really like to see you there as well. Okay, so we understand all these computing services, global infrastructure, networking. Now let's see the storage options we have and databases. As you can see, the breadth and depth, the number of services are huge. It is 200 plus services. It is not only finishing with services. Under services, we have different resources. You have to know, first of all, per use case, you have to know which services you are using and how you are configuring the underlying resources under that service. This is also important, because you have multiple compute options, you have multiple storage options, you will see multiple database options. So per your use case requirements and needs, you have to identify what is best for you, what is good fit for you. Now let's look at storage. We have instance stores and elastic block storage, EBS. It is also a famous one. So you have to know the difference. We have object storage, S3, simple storage service. You have to know this. It is one of the earliest published and major services like EC2 on AWS level. EFS, so NFS kind of system we have in storage. In databases section, we have a couple of SQL databases and also no SQL databases. And we will look at also other 6 Aurora. Yes, we will see Aurora options, Sonyan. So storage options. If you categorize storage options, we have 3 storage options: object storage, file level storage, and block level storage. Object storage is easy. We have only one, S3. If somebody asks you what is object level storage, yes, S3. And if you look at the market, all the vendors, they are trying to make their product S3 compatible. That is the market situation now. What is object? So you are uploading using this service API to put your files there. So if you see the shape, it is like a bucket. you can add data files, this file, and you're communicating with this way. This is the object level storage.
We lost 30 seconds.
Oh, sorry. It says your internet connection is not stable. Really sorry.
Okay.
So what I was rephrasing, so S3 is object level storage. You are talking with S3 API while putting your file, getting your file, changing your file metadata, these kind of things. EFS, we have also file level service. These are the file level service, EFS and FSX. Network file share system, NFS kind of file shares. Block level storage, the option is EBS. And we have also a couple of migration services. So if you want to move your data in and out to AWS to certain services, DataSync is going to help you. If you have really petabytes level data, the Snow family will help you. We will mention. And if you want to attach your local tape gateways, or if you want to do a storage extension, you want to use AWS as a backup extension, then storage gateway will help you. The other thing, we have also transfer family, FTP, SFTP. So you can use AWS transfer family for this kind of transfer as well. So in the exam, you will ask the difference between instance stores and Amazon EBS. Instance stores, when you launch an instance, it is coming on the instance itself. It is on the machine, on the hardware. So you are, if you want or not, it doesn't matter. It is coming with your machine. But these instance types are with I in the beginning, so you can easily recognize. So if you really need to write local, read local, and if you need a cheaper storage, this is a good option. But the bottleneck caveat is, if this instance is gone, this storage is also gone. Rest in peace. It is going. But EBS, it is another service. So your EC2 instance there, EBS volume is there, so they can, their life cycle, they are not dependent on each other. They are decoupled. I can attach my EBS volume to EC2, but I can attach to other places as well. I can do snapshot of this EBS volume. I can kill this EC2. I can put it new EC2, and I can attach this EBS back. So this is the difference. If EC2 is terminated, I am having still my data, and my data is still available on EBS. The difference is clear.
One question here, Burak. Is it possible to connect different EC2s with same Amazon EBS?
No, there is always one-to-one attachment.
Oh, okay. When we lost any ECU, we can keep Amazon EBS and we have to create new one.
The EBS will remain, this one.
Mm-hmm.
But then you have to take the operation to attach this to the another EC2 instance.
Okay.
It is under your responsibility and integration capability. So S3 is object level storage. You can put, as I said, image, text files, videos, binaries, whatever you want. This is the very famous object level storage in, of course, oh my gosh. Oh, is my PC stuck again? Okay, no. So in the S3, since we are putting data, but of course, everybody's usage are different from each other, right? Maybe I am putting all my files via using S3, but I'm not frequently accessing them. Or I don't need all the redundancy that S3 is providing me. So I want a cheaper class. So we have different storage classes inside S3. It is same service. You are putting your data, but durability, how you use your data back is changing. How you store, the standard is ideal for frequent access. If you want less redundancy, we have one zone infrequent access. We have also intelligent tiering. Intelligent tiering, you can create rules to move your storage classes. Let's say after 30 days, move to this one. After 30 days, move to this one. So you can create these step-by-step class change as well. For long-term archiving, really cheap solution, we have Glacier and Glacier Deep Archive. If you want to put your data and forget, then your service resource is S3 Glacier. You have to deploy your resources with S3 Glacier. They will ask you also in the exam, they will tell you, because of regulatory requirements, we have to keep data for, let's say, 20, 15 years. Nobody will look up back. Then the best place is S3 Glacier. You have to pick up the correct keywords from the questions. What is asked for, how they want to access, from where they want to access, how often they want to access. These are the keywords you have to really catch in the question. As we said, we have three kinds of storage: object, file, block. We have seen object, we have seen block. Now we are looking file option. In file option, we have Amazon EFS. It is a managed network file system. So we are creating this file level system that you can share between all your EC2 instances. That was one of your questions, Carlos. So if you want to use, let's say, a storage option, a block storage option, but you want to share that thing with all of your EC2 instances, then you can use EFS. You can attach same EFS to all your EC2 instances. That is possible, and it is a good way to handle. But of course, you have to do a trade-off. You have to do a cost comparison, also operation, because if you want to use S3 in your application, you need a logic to write, to talk, to be able to talk with S3 API, S3 put, S3 get, S3 put, get. But in the classical regular application, let's say in the data center, you have a regular application, it is already reading, writing files to a location, right? And nobody wants to do refactoring on the application, and the team is already gone. Then the best choice is, of course, choosing these kind of service. So based on the requirement, what is needed? Do you have a budget? Do you have people to support, to refactor the code? We are, based on these conditions, we are selecting these services. What is best? There is no best. There is no one best. The best is what is good for us, what is good for you, what is good for me. Relational database services. So we have seen the storage. Okay, we have a couple of storage options. How many databases we have? We have 6 database options. Amazon Aurora. So let's go to refactoring in cloud apps. Yeah, Onion, the situation is, if you have money, if you have enough resources to refactor that application, yes. We will see also at the end of the slides, we have cloud migration strategy, the 6R principles. Why not? You can choose new services. You can make it cloud native with choosing adding a little bit code to read write S3, right? But let's say you don't have time, you are in a rush, or nobody wants to spend on time this, you want to go collide, just simple lift and shifts. Okay, I have this VM, these instances, these applications, nobody wants to touch inside it. It is like a black box. You are moving your home from one location to another, right? The logistic guys, are they opening your boxes? No, they are not dealing, right? They are just holding your carton box and putting the truck, that's all. So if you want this kind of cloud adoption, then of course you don't need to refactor, just select whatever fits you after doing calculation, of course. Then when you create more time with selecting these managed services, because in the on-prem environment, you have to manage your Elastic file system yourself, right? But if you go to Amazon or any cloud vendor, when you get file management service, I don't need to give time, my effort, energy to managing this file service structures. So you see, I gain a little bit time. So if you add up all these small points, after moving cloud, you will have enough time to refactor or change something. That is the idea. I hope it answers your question, Honyin. So I will continue. Database options. We have 6 database options. We have Amazon Aurora. It is production level, proprietary, customized, MySQL and PostgreSQL developed from Amazon itself. We have PostgreSQL, MySQL, MariaDB, which is fork from MySQL, you know already, Oracle, or Microsoft SQL servers. We have 6 database options. What is database? Database, if we have some colleagues, they don't know database. Database is relational data collections that are helping us to organize our data, query, modify, and serve. And Amazon is helping us with Amazon RDS service to create these structures with these services, sub-services. So Aurora, PostgreSQL, MySQL, MariaDB, Oracle, SQL Server. Do you have a different DB engine, different DB vendor? Then, of course, you have to manage yourself. Just launch an EC2 instance, find the correct package, then install. That's it. But then, of course, you are losing the flexibility of managed service. Do we have only SQL relational databases? No. Amazon has no SQL database, DynamoDB, DDB, the shorter version. It is key value, also document-based store. If you know, in SQL world, we have to define the schema, the ER diagram, and we have to know before inserting, updating, selecting something from our relational database. In advance, we have to declare this to the DB engine. This is my schema, this is my tables, this is my column, and in this table, this is the varchar, this is integer, big integer, whatever the field. According to your DB engine, you select all these fields, right? So I have to declare this schema, otherwise my query will not work. But in NoSQL part, I don't need to define schema in advance. I just need a primary key, at least one primary key, to define my item or whatever it is, record in the NoSQL structure. And depending on the vendor, so if you choose MongoDB, let's say MongoDB has its own CLI, own language to do query. So you have different query options, not only SQL. So beside of SQL, you are getting different options. But if you are looking proprietary, high performance, sub-second, millisecond, fast responsiveness, fast responsive NoSQL, DynamoDB. You have to answer directly DynamoDB. It is supporting automatic scaling. If you want, you can allocate the capacity yourself. But if you don't want, it will manage the underlying infrastructure capacity for you, and it will dynamically grow and shrink for you. It is serverless structure, and it is heavily used in serverless world as well. The other database services, is it finished? Only with 6 SQLs. Databases with only one NoSQL DynamoDB? No. We have DocumentDB. It is MongoDB compatible. Amazon claims that. We have Redshift. It is mostly used in data warehouse structure, in data analytics part. Neptune, it is a kind of new service, a graph database, a relational database. So if you want to create these metadata connections between all your objects relations, the graph database is very famous now, familiar. So Amazon has service Neptune. If you want to build a ledger database, quantum ledger database, they have also managed blockchain. So manage means you don't need to deal with all these underlying infrastructure, operating system, DB runtime, DB packaging, update, backups, operations. So all these tasks are handled by AWS. So you are just an end user of these databases, that's all. But if you are looking at in-memory cache, we have Elastic Cache. In Elastic Cache, we have Redis or Memcache. So you can choose either between 2 flavors. You are not obliged to select one. In the exam, you will get this question, most probably DynamoDB accelerator. So you want to get highest performance from DynamoDB. The shortest name is, I think, DAX. If you enable this, your response time will be really microsecond in DynamoDB. And the beauty of DynamoDB as well, you can create a global table. The DynamoDB itself will replicate this global table across different regions. So you can have a DB. It is not only bounded to one region. You can replicate, Amazon is replicating this DB and all the tables items behind the scene for you. And if you want to move your databases, if you want to change your databases, if you want to convert your database structure, DMS, Database Migration Service, is the best fit for you. Let's say you want to go from a licensed enterprise version database, I will not tell a name, and you want to convert to the open source version in Amazon. So with using DMS, it will create a DMS server in your Amazon account. You will connect, you will show the source location where your database resides, and you will select target location. If you want, you can do schema conversion. You can change your database structure. Then you can migrate your database with this way, using DMS. This is also part of under database services, but it is also part of migration services, actually. So we have a quiz. Which of the following services falls under the responsibility of the customer to maintain operating system configuration, security patching, and networking? Amazon RDS, AWS ECS with Fargate Launch, Amazon Elastic Cache, Amazon EC2. So we want to be responsible from operating system, security patching, networking. Which is the best fit for us? Yes, William, Carlos, E. Do we have other voters? Yes. So the answer is yes. If you want more responsibility, the best option is always EC2. That is correct. Thank you very much. And the other question, which one is the NoSQL database service from AWS? Amazon RDS MariaDB, Amazon Redshift, Amazon DynamoDB, Amazon Aurora. What will be your answer? NoSQL database service. The famous one. C. Yes, I agree. It is Amazon DynamoDB. And I think we have a lab. We will launch an RDS DB together. We will see options. And we will check some configuration items. If everything goes well. So I want to launch a database. So I went to RDS, as I said. There are many ways to interact with AWS. I want to point again. So because of showing purposes and getting you used to this environment, we are showing you over this console, but this is not the best practice to create resources in the cloud. So let's, for testing and showing purposes, teaching purposes, we went to console and we typed here RDS. If you want to go, you can click on services part. Here on the database, you can narrow down your selection. But I don't want to narrow down, so I want to land on generic RDS dashboard. And here, you can see the summary, the facts and figures about your current databases. And I want to create a database. So here, what I need to select, here, it is giving me which option. As we said, we have 6 engine options, DB engine. Amazon Aurora, under Aurora, we will see 2 flavors, MySQL and PostgreSQL. These are developed by AWS engineers and fully managed. Of course, all these selections are fully managed by AWS itself. It is not like launching an EC2 instance and installing your DB engine, DB runtime on it. So, but on Amazon Aurora itself, we have different logics, and they have they have more capabilities when you compare the plain PostgreSQL or MariaDB. So let's select Amazon Aurora. And in Amazon Aurora, we have selected MySQL. So the first selection is engine selection. And here we can select the version itself. Which version do we want? We want dev test. Based on this selection, it will give us an option. We can specify our database name, we are fine. Master username, admin, we are fine. Auto-generate password, let's auto-generate. Now, after selecting instance type, the connectivity, we have to select which kind of DB instance we want. So we have EC2 instance types, we have seen this. We have different instance types. We have also different database instances. So you have to select the machine structure for your databases. Then this is also included. Here it is asking you multi-AZ deployment. Do you want multi-AZ or not? So Aurora is giving a read replica. Read replica means it is creating a master node. So master node is responsible for write operations as well as read operations. But if you want to decouple your write and read operations from each other, we have this option. So, and if you want to create this more, let's say your database is really read heavy, then you can think of this option. I will select this to show you the read structure. Here we have to select the networking. I will select my existing network structure. Create new subnet group, I am fine. Public access, no. VPC security group, create new. EB security group. We will connect with database with our password authentication. So in additional configuration, it is asking us backup. If you want the backup, this is showing the backup. If you want to encrypt database, you can use default encryption key, or you can use a different encryption key as well. That is also possible. Monitoring. What is the granularity level you want to monitor your database? Do you want to export all these internal engine logs? And are you going to do auto upgrade? Since it is a managed service, it is asking us, do you want to manage yourself all these upgrade scenario or not? It is up to you. If you are not going to select this, in the maintenance window, if you don't have any preference, of course, it will take whatever's best for Amazon, but you can specify exact time to do these kind of management activities. So I am fine. Let's say start Saturday, start time around 1, duration. So the maintenance activity, these kind of backup, snapshot, all the maintenance upgrade, they will start first with all these replica. I am fine with the rest. So we selected DB engine. After DB engine selection, we selected DB machine itself. We configured networking part where we will place this database in our networking. How we will reach it, the configuration, access configuration, encryption, and maintenance window, all these settings. Then we launch this. It will take a couple of minutes. It is not one click. Of course, it will take a couple of minutes. If you have any questions, meanwhile, I can get, and we can stop here. So here, if you look at, I created this database with read replica. So I have one writer, one reader, and it is spread it into 2 zones. It is using 2 availability zones. And if you look at the endpoints, I have one endpoint for writing, and I have one endpoint for reading. So in your application, you can define this logic. So if you need to write something to database, you can use this endpoint. If you need to read something, you can use other endpoint instead of write. Because if you choose AWS Aurora, RDS Aurora, you can have multiple read replicas. So you really can scale your read capacity with the help of multiple read replicas. You don't need to worry if read is going to create bottleneck or not. It will create basic monitoring dashboarding for you. If you export, if you remember, if you select the export all these logs event, you will see here the basic configuration what we have selected. You can also see a short summary in the configuration screen here. Maintenance backups, it will show you what we configured here and what is the next maintenance. It can be a version upgrade, it can be backup. So we also configured backup. Just compare this easiness with what we were tackling in our on-prem data center. Each of them is nearly a separate project, like taking a backup, to be able to restoring from backup, monitoring database, all this connectivity, configuration, deployment, read replica. Even in our on-prem environment, making this read replica high available, it is really a good job for DB administrators. So if I want to change something, let's say if I want to add reader, I can change, I can stop the database. It will stop the charging. If I need to change configuration, I can say modify. Okay. So in AWS security, I think we can stop here. And we can continue in the follow-up session. Is that good, or shall we finish also security?
Up to you if you have a time.
Yes, William, it is late. So we have a follow-up session. Oh, William says no, continue. Let's vote. Shall we continue half an hour? Because that is what we planned, scheduled, what we promised. Yes. Network ACL, it is only defined only one place while you are deploying something, either Lambda, EC2 database. You cannot see this until you hit this network ACL rule, because
Okay.
network ACL is outside subnet, as we said. But if you want to change something traffic level in DB level, EC2 level, it will of course always ask security group.
Okay, clear. Thank you.
So William says continue. Yes, Honyan. So we have a session on 5th of July as a follow-up session, and we will finish all the rest of the slides, and we will solve practice. We will solve some questions together with Q&A. So it will be more interactive than this one. So half of the community is saying continue. Gökhan saying if we have second session, we can stop here. Okay, it is democracy, so we are voting here, Gökhan. Alex says continue. Okay, so let's try to finish. The majority of our participants is fine. So let's also go with the security, then at least we can create more room in our second follow-up session for solving questions. and doing more Q&A. Is it good? Yes. So let's ramp up. I think database part is clear, right? We have SQL options, we have no SQL options. Beside of these no SQL, we have also other database options. Based on your requirements and needs, you deploy your database service, that's all. And all the hustle, management, underlying infrastructure, backup, maintenance, let AWS do for you. Then you can focus your application and you can focus your what is important for you. AWS security. Security is also one of the important topic in the exam. We have to understand shared responsibility model, how user permissions and access is working, directory services, cognito, organizations. We have many topics here, but you can watch back how we can protect our workloads in cloud, because when we cloud, one of the myth is it is not secure, because it is like in the middle of a desert. Everybody can see. There is no hiding place. Is it true really? Do we have enough mechanism and services to protect the workload? How we can protect also abusing attacks, DDoS, denial of service attacks, and other security services you need to know for passing this exam, also for using later on. If you are going to cloud or going to start to use cloud, regardless of cloud vendor, you have to understand this shared responsibility model. AWS gave this jargon, security of the cloud, security in the cloud. So the left-hand side is under responsibility of AWS. So selecting regions, availability zones, protecting data centers from terrorist attacks or water floods or thunderstorms, selecting edge locations, making contract with service providers, making hardware vendor contracts, SLAs, and putting hypervisors, maintaining all these infrastructure, plumbing, networking, putting all these storage cabinets, and the management layer of AWS, the cloud management layer. Amazon is responsible. So Amazon Web Services are responsible of all these items, at least the minimums. Depending on the service, as I said, let me stress again, depending on the service that you are going to select, even the resources that you are selecting in the service, this responsibility either is in your side or AWS side. It is not always 50-50, sometimes 70-30, 75-25. These kind of responsibility percentages we have. In customers, as a customer on the right-hand side, what we are responsible, what I am putting in the cloud. I have deployed a database. Okay, managing the database is under responsibility of AWS because they are providing this service for us. It is clear. But in the networking part, if I put this database to the public and in the security group, if I allow connectivity from everywhere, and if somebody hacked my database for any reason, can I claim or blame? Can I claim anything from AWS? Can I blame AWS? No, because this is my fault, basically my fault. I should follow best practices. I should listen. The experts, what they are saying, they don't put your database into public subnet. Simple, right? So as a customer, I have to know which service I am selecting and what is my percentage, what is my take in this responsibility, depending on the service. So let's say you selected EC2. Of course, the hardware, hypervisor, virtualization is under responsibility of AWS, but we selected an operating system that is my responsibility. Arranging firewall rules, that is my responsibility. The applications is my responsibility. Maybe I'm using Java 5, 6. I'm using log4j, the vulnerable packages inside my application, and my application got hacked, which is running on EC2. Is it my problem or is it Amazon problem? My problem again, because I didn't upgrade my Java runtime. I didn't mitigate all these vulnerabilities myself, and I cannot blame Amazon because of this fault. It is my responsibility. It is my data, my applications. So this differentiation we call shared responsibility model. It is really important you have to understand this difference, and it is changing based on service. User permissions and access. In Amazon, if you want to use Amazon, as we said in the beginning, if you don't have an account, please go and create an account. The first account is your root account. So, but after getting root account, Amazon is suggesting you to create multiple accounts to differentiate workloads in different accounts. Let's say you can separate accounts either based on business departments or based on workloads. It is up to you. Or you can run everything in the same account. Or you can have at most 3, like development account, testing account, staging, production, maybe 4. The divide of these accounts, how you separate all these accounts, or are you going to only one account? AWS is providing best practices for us, and they are providing IAM service, identity and access management. With identity access management, we can able to create users, groups, we can create policies, roles, and we can authenticate with single sign-on services. So I can integrate my Active Directory or LDAP to log into AWS via easily. So I don't need to recreate all these users. So I can use my existing company level structure. So IAM policies, basically they are allowing or deny structure when using AWS APIs. So as a customer of AWS, we are responsible to always follow best practice, least privilege. So if you need to launch an EC2 instance, I should only be able to get these permission structure, not, let's say, creating or launching an RDS. This is different. Why do I have to give you an RDS create launch permission? Also maybe creating or deleting S3 buckets. So giving enough permission or required permission is least privilege. That is the technical jargon you have to know. And we are providing this capability with IAM policies. So if you go further in Amazon world, you will see resource-based policies, permission-based policies, but mostly we are working with permission-based policies. So we have users, we have service applications, we are letting them to call API, to use a resource. We give this control check with policy. If you don't have right policy, you cannot use, you cannot make a call. What is role? Role is, I am not that user, but I don't want to give that permission. So, but I want to give my card. It is like, I have special access to special doors in a big palace, let's say, right? And you give me a badge, but it is your badge. Since it is your badge, I can able to enter those places like you are entering. When I enter, I will leave my footprint, but it will be on your name because I'm using your badge. So it is like this kind of mechanism. So I am assuming a role. It is a hat, as you can see. With this role, I am acting like I'm having these permissions. Normally, maybe I don't have these permissions. I don't need necessarily all these permissions always. So what I am doing, just for finishing this task, I just assume a role, do my job, and leave the role back. This is the structure. And if you want to protect, of course, your account for other activities, we have multi-factor authentication. When you do login, instead of just only providing your email and password, you can also use SMS or email verification. It is two-step approach. And I think we mentioned also root users, so we are passing this. Directory services, as we said, if you have, let's say, Microsoft Active Directory, you can use your Active Directory. You can make a trust between your Active Directory with the AWS Active Directory service, one-way trust, two-way mutual trust, or you can manage your directory structure from Amazon itself. They have also managed Microsoft AD service. That is also possible. Or if you don't want to mess or mix, let's say, your directory structure, then we have AD connector. This AD connector will help your resources running on Amazon to able to connect to your Active Directory. These two things you have to keep in mind in the Active Directory and directory services. Enough for exam. Cognito, let's say we develop a web application, we will have thousands, millions of users. And they are going to access our resources in AWS. Do we need to create LDAP user for all of them? Or do we need to create Active Directory user for all of them? How we will manage all these user structure? Then the best service is Cognito. You are a mobile developer, you need to authenticate your users, but you don't want to do user management yourself. Okay, offload the task. AWS Cognito is for you. Just use this service. They have designed this for you. AWS Cognito. So in the exam, if you see, or in the real life, if you want to offload this user management to another level, like user identities, user management, password verification, all this stuff, Cognito is the best place. You can ask question, if AWS is suggesting us to create multiple accounts, then how we will manage all these accounts, right? What is the best structure? So, and if I want to apply policies over different accounts, what is the best way to do? We have AWS organizations. So in AWS organizations, what we are doing, we are creating an organization structure like your current organization structure in your company. It can be business departmental or logical, whatever you want. You can replicate your current organizational structures here on Amazon, or you can define different structures, a functional, logical business. And based on this organizational unit OUs, you can define policies. It will be effective and over IAM policies. So it can override IAM policies. Let's say I am in infra account here. Normally, I am an admin in this account. I have full access to all the resources, but my account, infra account, is connected to an AWS organization. And I want to delete, maybe I want to add some users, maybe I want to change some user policies. So how I can protect this. Even maybe I have admins from offshore places. Yeah, I trust my admins, but I don't want to give also IAM permissions to them to change others' passwords or other things, let's say, to add other accounts. So I want to restrict these things. Then the service control policies will help you. It will take away and protect you on higher level. Do you have any questions till now? Security is a long topic. Let me check what we have left in security. Okay, not much. 2 more slides, then we will finish. So if you want to check the compliancy, like PCI, healthcare industry, personal identifiable information, or credit card transaction, all these compliance things, we have artifacts, AWS artifact. You can check all these regulatory agreement in the AWS artifact. Maybe you have a legal department is asking the legality of the using AWS in the region or that service. So you will find this kind of agreements, third-party audit reports in AWS artifact. Denial of service attacks. So what is denial of service attacks? Denial of service attacks, hacker or abuser of the system, whoever it is, we call hacker. They are sending legitimate or not legitimate kind of request, and they are prohibiting other normal regular users to consume our services. The way what they are doing and what they are doing, name is denial of service. So the regular users cannot get the satisfaction from our services, APIs, applications, whatever it is, because of this attack. Either they are using bot or they are using other mechanisms. Then if you get this kind of traffic, because what we said, everything is metered billing, right? Let's imagine you have an auto-scaling group and your auto-scaling group maximum capacity is 1,000 and your application is public, a website, booking website, and you are getting millions of bots making booking. What you will do, you will scale your applications in web layer, application layer, and also you can do DB scale. Then, of course, you will pay lots of money for nothing. It is a DDoS attacks for your service, and you will lose money because why? Because you scaled and you use cloud services. It is simple. So how you can protect? In AWS side, we have AWS Shield. The Shield standard is applicable to you, to me, everyone having an AWS account. You don't need to enable this. You don't need to tick box somewhere. It is automatically enabled. So Amazon is protecting, Amazon Web Services, AWS is protecting their network already. So you don't need to much worry. So if they get a DDoS attack to your application, they already detect before you detect yourself. They try to mitigate because at the end, the DDoS attack to your application hosted on AWS, it is an attack to AWS itself, network, right? So you are getting a standard service, but if you want more, we have Shield Advanced service. AWS has dedicated team for protecting you and assisting you while you are getting DDoS attacks. And they are also giving advice to use which services in which correct points, how you can protect your workloads and how you can stop this or mitigate, or let's say with less vulnerabilities. Additional security services. So we understood that AWS is protecting us with AWS Shield. We have also other security mechanisms for creating users, giving policies. But do we have other things to protect or watch over? Yes, we have. The first one is AWS Key Management Service. It is really important service if you want to manage your encryption keys yourself. It is a managed key management service. So yes, managed key management service. You don't need to deal. Let's say I have a key, and normally on-prem environment, if you want to manage your keys, you need an HSM, hardware security modules, where you store your cryptographic keys, these security keys in that boxes, right? You have to maintain those boxes yourself. And you have to rotate all these keys yourself securely. On-prem, these are tasks, your duty, you have to do. But you can also continue to do same hustle in cloud, that is possible. AWS KMS, AWS itself is allowing you to select your own keys, rotate your own keys, put in your own HSM box. It is giving you this flexibility. But if you don't want all these things, I want to use one simple key and I want to encrypt my, let's say, objects in the S3 bucket. Then okay, just create a key via help of KMS, then use that key. So the rotation, protecting that key, managing that life cycle of key is under responsibility of AWS. That is the beauty. The other service, important service, AWS WAF, Web Application Firewall. So when we protect our applications, we are not only protecting in infrastructure layer, right? Network ACL, security groups are one level in infrastructure layer. Also, you can put firewall, other vendor firewalls, but we have also attacks in application layer, right? So how you can detect them, how you can mitigate them. So AWS WAF is the correct service to do this. Inspector, we have also other service, Inspector. Inspector is running an agent in our EC2 engine, EC2 instances, and that agent is creating reports, security reports, basically. What is the traffic? What is happening in our instances? Which packages vulnerable or not? And guard duty is machine learning supported security service. If Amazon detects an unusual activity in our accounts, it will notify us. And it will try to mitigate as well. That's it. Now we will really stop. So we finish 6 topics, the 4 topics left for 5th of July. I hope you found it useful and enjoy. AWS Cloud Practitioner exam is easy.
Well, thanks a lot for teaching us.
Welcome, William. So we have 4 topics left. In 5th of July, 6:30. I hope we will see each other. Yes, Honyen, you will get an email. If you search YouTube ITGilde, you will see a channel. And today or next week, you will find this video as well there. So if you can able to afford also join next follow-up session, we will finish the remaining 4 topics. After finishing those 4 topics, we will solve practice questions like you will see in the exam. The exam questions like the one I asked in the quiz, it is really easy. You have to know which kind of databases, what is RDS, what is NoSQL service. You have to know this knowledge, nothing the fancy features of all these services. That's all, because it is just a stepping point for you to the cloud world. You have to start somewhere, and this is a good beginning.
Okay.
Yeah, that was so beneficial. Burak, thank you so much. And we have a lot of time up to 5th of July, right? That reason, maybe we have to make some practice to create some
Yes.
account in the Amazon.
Sure.
AWS has free training. If you search AWS free training, you will see Cloud Practitioner Essentials training. You can follow up. And if you search YouTube, you will see lots of practice questions also there. You can follow up AWS official free training if you want to become more ready for the next session. You're welcome. Then you can take the exam immediately, because the exam is really easy. Similar questions.
Okay. Yeah.
Okay.
Cool.
Thanks very much.
Chris, do you have any question?
No, I said thanks very much, and I'll see you in July.
Okay. Thank you very much, everyone. Thanks for joining. Thanks for your time.
It's
See
been
you.
very useful. Thank you very much.
Okay.
Yeah, see you in the next session.
See you all next time.
Bye.
Bye. Have a good weekend.
Bye.